Alright, so welcome back. So we are still on the series of Binomial Theorem, and then on our last video we are on how to find coefficients of terms. So I give a special formula on how to find the coefficient of term. Now we'll be solving a more complex question on that, how to find the coefficient of term. Then they will ask you to find the constant term. Then they will ask you to find the term in maybe x to the power of 5, x to the power of 6, and so on. So here's the problem. So now we are asked to expand 2x squared minus 1 all over 2x all raised to the power of 12. So now the I, they said we should find the 8th term. Yeah, that's the I. They said we should find the 8th term. The 8th term. And then the II, we are asked to find the constant term. And then finally we are asked to find the term in x raised to the power of 6. So we'll be solving this together. Now this is more complex than the one we did previously. So in case you missed that video, you can just click on the link in the description or the video card that will be displayed here. Now let's proceed. Now for us to solve this problem, I'll be using that same formula I did on the previous video. So for the I now, you have to find the 8th term. For the 8th term, this will now be the result. Or to find the 8th term. To find the 8th term. Now you recall the formula. Recall the formula that the kth term of any binomial expansion is equal to n combination k minus 1 e raised to the power of n minus k minus 1 b raised to the power of k minus 1. So now this is the formula. You can just go back to the previous video, you see how this was gotten. Now let's proceed. So I'll be using this formula now to find the 8th term. You don't need to be expanding this. You expand every single thing before you get the 8th term. You don't have that strength, you don't have that time to waste. So with this formula, you can just impute it inside, and then boom, you get the 8th term very fast. Now, let me show you how to use this formula. You know that given this formula now, you are seeing k, you are seeing n, you are seeing a, and you are seeing b. So I always say this, when you are given an expansion, you have to expand this. Look at the bracket. The one with higher index is called your a. Then the one with lower index is called b. So looking at this now, 2x squared minus 1 over 2x. 2x squared is obviously a because this is the one with higher index. Then 1 over 2x is b because it's having a lower index. So this is a, this is b. Now you have not a and b. Now in the formula you are seeing n. You know that n is the index here, which is 12. So n is equal to 12. And the next one is k. So your k now is the term you are asked to find. You are asked to find the 8th term. So k is literally 8. Now I've gotten all those values. Let me just bring it here. You have known that a is equal to 2x squared. And then b is equal to minus 1 over 2x. Don't forget that. Don't forget to keep the minus sign. It's with it. Minus 1 over 2x. Then the next one is n. We know that n is 12. And then finally, k is 8 because you are asked to find the 8th term. So k is 8. Mind you, there is something I'm going to explain in course of this video. When they say find the 8th term, this is the approach I'll give. But in this case now, you are asked to find the term in x raised to the power of 6. This is far different from this. I'm not going to approach these two questions in the same way. It will be different. So in case you want to skip this video and you say, maybe when I've gotten the constant term, you say, okay, I can find this. You're obviously trying to just waste your time, because once you see a question in term, you say find the term in x to the power of 6. It's a different approach altogether. But when they say find the 8th term, I'm going to do this I'm doing right now. So now k is 8. Now let's impute all this into the formula. So I'll have 12 combination. K now is 8, so I'll have 8 minus 1. Then A is 2x squared, all raised to the power of n, which is 12 minus K minus 1, that is 8 minus 1 in a bracket. Then B is what? Minus 1 over 2x, all raised to the power of 8 minus 1. So I've successfully fixing all the values. So I'll have 12 combination 7, then 2x squared, all raised to the power of 12 minus 8 minus 1 is 7. 12 minus 7. So I'll have minus 1 over 2x, all raised to the power of 8 minus 1 is also 7. So I'll have 12 combination 7, then 2x squared, all raised to the power of 12 minus 7 is 5. So this is 5. And then I'll have minus 1 all over 2x, all raised to the power of 7. Now, for me to simplify this, I'll have minus 1 raised to the power of 7 first. Minus 1 raised to the power of 7 is obviously minus 1. And let me explain that. When you have an index of an odd number and you're having minus 1, let's say you have to find minus 1 raised to the power of 9. This is an odd number. Don't stress yourself. Your answer is just minus 1. It's minus 1. But when you have minus 1 raised to the power of an even number, let me say 8 or 10, you know, even numbers 8, 10, 6, 16, 24, all those ones are even number. So now when you have something like this, your result will be plus 1. Just take note of that. Those two things, you really need it. Now let's continue. So now we have minus 1 raised to the power of 7, and we have known that the result is minus 1. 2x all raised to the power of 7. 2x raised to the power of 7. I'll have 2 raised to the power of 7 first, and 2 raised to the power of 7. The result is 128. So here I'll have 128. Then x raised to the power of 7. X raised to the power of 7. So now let's proceed. Now I'll have 2. Okay, this is 12 combination 7. Now 2x squared all raised to the power of 5. 2x squared all raised to the power of 5. I'll have 2 raised to the power of 5 first. After that, I'll have x squared raised to the power of 5. So now 2 raised to the power of 5. We do that, 2 raised to the power of 5. The result is 32. My punching calculator for this is 32. Then 32 multiplied by x squared all raised to the power of 5. You have x raised to the power of 10. How is that possible? X squared raised to the power of 5, you just multiply the index for your basic knowledge of indices. And now this is multiplied by minus 1 all over 128 x raised to the power of 7. That's it. So now moving on, now I'm going to find 12 combination 7. How will you find 12 combination 7? So we discussed that in our previous video, but let me also do it here. So now let's find 12 combination 7. So 12 combination 7, now I'll drive your mindset back to the general combination. So when you see something like combination, if I have n combination arrow, the result will be n factorial all over n minus arrow factorial, arrow factorial. This is the general form of combination. So now I'm asked to find 12 combination 7. So my result will be 12 factorial all over 12 minus 7 factorial, 7 factorial. That's it. Then if it's permutation, if I'm giving n permutation r, the result will just be n factorial all over n minus r factorial. That's for permutation. So you understand the difference between permutation and combination. So now 12 combination 7, now I have 12 factorial all over 12 minus 7 factorial, 7 factorial. So now 32x raised to the power of 10 multiplied by minus 1. This is, I'm multiplying this by minus 1. So if I multiply it, I'll have 32x raised to the power of 10 minus 32x raised to the power of 10. So here I'll have, this is a multiplication sign. Then I'll have minus 32x raised to the power of 10 all over 128x raised to the power of 7. So that's it. Now let's continue. So let me assume I'm not using calculator, because some stuff like this you may want to make your work to be easier. So now I'll have 12 factorial is the same thing as 12 times 11 times 10 times 9 times 8 times 7 factorial. Let me stop here at 7 factorial, because there's 7 factorial in the denominator, so that they can cancel out. And this will now be divided by 12 minus 7 is 5 factorial. So I'll have 5 factorial as 5 times 4 times 3 times 2. Don't need to put times 1. It's not necessary. And this is multiplied by 7 factorial. 7 factorial. Now let's cancel out 7 factorial. We cancel 7 factorial. 5 we're going to 10 2 times, and then 2 we cancel the 2 up there. 4 we're going to 12 3 times, and then 3 we cancel the 3. So now I'm left with 11 times 9 times 8, and this is multiplied by minus 32. You know that when you have x raised to the power of 10 divided by x raised to the power of 7, by your general knowledge of indices, you can just subtract the index when you are dividing. Yeah, so I'll have x to be raised to the power of 10 minus 7, and this is divided by 128. There's nothing I did. It's just very simple. Just subtract the index. X raised to the power of 10 divided by x raised to the power of 7. I'll subtract the index, 10 minus this. So now I have this. Now let's multiply. 11 times 9 times 8. The result is 792. And this is multiplied by minus 32x cubed all over 128. So now let's see if this can be divided by 128. Okay, it's a decimal number. So now I'll multiply this by 32. So now 792 times 32. The result is minus, there's a negative sign, so I'll have minus 5 minus 2, 5, 3, 4, 4. X raised to the power of 3, all divided by 128. Now let's divide it by 128. The result is 198 x cubed. Don't forget there's a negative sign here. So that becomes the answer. Now the 8th term in this expansion, the expansion of 2x squared minus 1 over 2x all raised to the power of 12, the 8th term is now minus 198 x cubed. Now if you observe, like I said before, when they say find 8th term, 7th term, 6th term, 4th term, 3rd term, it's different from when they say find the term in x raised to the power of 6. If you observe now, the 8th term of this expansion is now the term in x raised to the power of 6. Sorry, it's now the term in x raised to the power of 3. So it's different from when they say find 4th term or 8th term or any stuff like that. Now let's move to the next one. The next one is to find the constant term. Now let me brief you on how to find constant. Let me just brief you on constant term. If I'm asked to expand this, let me say, okay, let me clean the board. Now, in finding the constant term, let me brief you on something. For example, I'm asked to expand a plus b all raised to the power of 2. Okay, let me say a plus 2. A plus 2 or square. If I expand this, my result will just be a squared plus 4a plus 4. That's the result. Yeah, if you expand it, this will be your answer. Now, I want to explain constant term for you. When you hear the word constant term, is a term that has no x, that the index of x is 0. So looking at this expansion now, the constant term here is 4, because 4 has, like, 4 is just constant. There is no x with it. So that's just the layman understanding. Just have that in your head, that the constant term of an expansion is the one that has no x with it. So the constant term here is 4. So now let's go back to this original question. 2x squared minus 1 over 2x all raised to the power of 12. If I expand this, there will be a value. There will be a value of this inside the expansion, that there will be no x with it. That one is now called the constant term. So if you go back to this, if there's one short video I did on my channel, I will just put it in the description, you will see it, where I gave a number like 6. So I showed all the invisible numbers, all the invisible features with this number. And let me bring it here now. Let's say we are given the number 6. These are the invisible features with this number that they don't need to write out. There is an invisible plus here. We don't need to write it out. There's an invisible denominator of 1 here. We don't need to write it out. There's an invisible index of 1. We don't need to write it out. There's an invisible x raised to the power of 0. We don't need to write out. There's also an invisible base of 10 here. We don't need to write it out. Now, looking at this now, it's looking like a chemical compound stuff. So these are all the invisible features with a number that they don't need to write out. Now, the more you are solving, the more you are advanced in mathematics, you observe that we're bringing out
You want to kill yourself?
You're bringing out each of these features. Yeah. Now, when you do addition and subtraction, you observe that they always bring out this plus sign. When you do fraction, you observe that they'll bring out this denominator of 1. When you do indices, you observe that they'll bring out this index of 1. Then when you do number bases, that's conversion from base 10 to base 2, like that, see that they'll be bringing out this base 10. And when you do calculus, you observe that they'll bring out x raised to the power of 0. And now, in this case, now I want to bring out x raised to the power of 0. Now, why did I say this? This 4 is the same thing as 4x raised to the power of 0. That's just the thing I wanted to see. The reason why I said all this. Now, this is now, okay, in this case now, it's not x, it's a. I'll use a. So now this is now 4a raised to the power of 0. Now, for every constant term, you can take note of this. For every constant term, you will equate your expression to 0. Just know that. For every constant term, there's an index of 0 here. That means after solving what I'm about to solve now, you must equate your result to 0. Just get that. Now, let's solve this now to find the constant term. Now, there is something that is kind of strange here. But let me bring out all the parameters. You observe that when we did, I'll still be using that formula, that combination formula. I'll be using that formula. But in that formula now, we are giving A, we are giving B. Let me just bring it out. You see, this is the II to find the constant term. So to find the constant term, I'll bring out all my parameters. So I'll have A as 2x squared. I'll have B as minus 1 over 2x. Then you have N as 12. Then now, what will I use as my key? What will I use as my key? Now, in this case, now your task is to find the value of key first. Yeah. So how will I get the value of key? Now, let me show you how to get that. So I'll just use these 3 values, put it inside that my combination formula. So don't forget the formula, just recall. You recall that the formula we use is n combination k minus 1 e raised to the power of n minus k minus 1 b raised to the power of k minus 1. So now let's put the values inside. So now n is 12. I'll have 12 combination k minus 1. I don't know the value of k. This is for the constant term. I don't know the value of k. So I'll say k is just k. And then we know that a is what? 2x squared. Now this is raised to the power of 12 as n, that is n, 12 minus k minus 1. We don't know the value of k, so just put it the same way it is. And then b is minus 1 over 2x. And this is now raised to the power of k minus 1. So let's continue. I'll have 12 combination k minus 1, 2x squared, all raised to the power of 12 minus k plus 1, because minus times plus, minus times minus is plus, minus times minus is plus. So here will be minus 1 over 2x, all raised to the power of k minus 1. So here I'll have 12 combination k minus 1. Now 2x, okay, 2x squared raised to the power of 13 minus k. Yeah, 13 minus k, because 12 plus 1 is 13, then we have minus k. Now, let's go here. We have minus 1 over 2x all raised to the power of k minus 1. So by your basic knowledge of indices, when I have a all over b all raised to the power of c, I'll have a to be raised to the power of c, and then b be raised to the power of c. This is, yeah, that's it. So now, in doing that now, I have minus 1 to be raised to the power of k minus 1. Yeah, and then 2x will be raised to the power of k minus 1. So now when minus 1 is raised to the power of k minus 1, what will be the result? Let me just give you the result for that. Anytime I have 1 raised to the power of anything, okay, let me just say I have 1 to be raised to the power of minus 20. What will be the result? The result will still be 1. If I have, this will still be 1. If I have 1 raised to the power of 2x plus 5y, 1 raised to the power of 2x plus 5y, my result will still be 1. Because 1 raised to the power of anything is still 1. 1 raised to the power of anything is 1. 1 raised to the power of 0 is 1. 1 raised to the power of heaven and earth, 1 raised to the power of earth is 1. So now 1 minus 1 now raised to the power of k minus 1, I'll still have minus 1 as my result. So here I'll have minus 1 all over 2x raised to the power of this. That is 2x raised to the power of k minus 1. So moving on now. Now let me split this. I'll have 12 combination k minus 1. Then 2x squared all raised to the power of 13 minus k. This is the same thing as ab all raised to the power of c. I'll have a to be raised to the power of c, and then b raised to the power of c. Your normal indices. Now we have 2x squared all raised to the power of 13 minus k. I will have 2 to be raised to the power of 13 minus k. And then x squared will also be raised to the power of 13 minus k. That's it. So now we have our minus 1. There's a multiplication sign here. Minus 1 all over that. So I'll have minus 1 multiplied by 2x all raised to the power of minus k minus 1. Now don't be confused what I did here. When you have a division and you're moving this upward, this is the same thing as minus. Okay, let me give you a simple example. If I have 1 all over a, 1 over a is the same thing as a raised to the power of minus 1. So you have the clean. Now when I have 2x, when I have minus 1 raised to the power of minus 1 all over 2x raised to the power of k minus 1, I'll just bring it up. Then this, I'll include a negative sign in the index. That's it. So moving on now, I'll have, let me just bring this minus 1 to the front. So here will be minus 1, 12 combination k minus 1. Then 2 raised to the power of this. I don't need it. Let me just write it back. 2 raised to the power of 13 minus k. And then x raised to the power of that, I'll have x to be raised to the power of 26 minus 2k. Minus 2k. 26 minus 2k. If I expand this, 2 times 13 is 26. 2 times k is minus 2k. Remember, this minus 1 is already here. Now, let me expand this. 2 raised to the power of this first. I'll have 2 raised to the power of minus k minus 1, because minus into k minus 1 is minus k plus 1. Yeah. Minus times this is minus k. Minus and minus is plus 1. And also, x will also be raised to the power of the same thing. Minus k plus 1. Yeah, that's it. Now, let me bring the one with the same base together. So now this one and this one are having the same base. This one and this one are having the same base. Let me bring them together. So I'll have minus 1, 12 combination k minus 1. And then here I'll have 2 raised to the power of 13 minus k. You also have a 2 raised to the power of this. So I'll add it together. This will now be minus k plus 1. I just added the index. Remember, indices, when the bases are the same, add the index. And you're multiplying, you add the index. Now for x, I'll have x to be raised to the power of 26 minus 2k, I'll add this, minus k plus 1. That's it. So now moving on, now I'll have minus 1, 12 combination k minus 1, 2 raised to the power of 13 minus k plus 1 to be 14 minus 2k, because 1 plus 13 is 14, minus k is minus 2k. Then I'll have this, so you multiply by x raised to the power of 26 plus 1 is 27 minus 3k. So I have gotten to this extent. Now this is here I was just hoping to get to, and I've successfully gotten to this extent. Now when you get here, you are having the index of x as 27 minus 3k. Remember when I was introducing this constant term, I said the index of every constant term, that is, when I did that example, I had a plus 2 all square. I had a squared plus 6a plus 4. So I said this 4 is the constant term. So now I said that an invisible 4x raised to the power of 0. So the index of every constant term is 0. That means the index of x is 0. So since I'm asked to find the constant term here, I'll just say the index of x is 27 minus 3k. So I'll now say 27 minus 3k, I'll equate it to 0. That's just it. Now in this case, when they say find the term in x raised to the power of 6, I'll equate the index of x here, that is 27 minus 3k, I'll equate it to 6 this time around. That's just it. Now if they say find the term in x raised to the power of 12, I'll just equate 27 minus 3k to 12. So now you understand everything I was listening. Now in this case, when they say each term, that one is different. No? But when they say find the term in like the index, you do like this. Then I'll make k the subject, and then I'll have 3k to be equal to 27. So k will be equal to 9 when you divide both sides by 3. You already understand all this aspect. Now I'm going to put the value of k back here. Now put the value of k back here to get my final answer, which is the constant term. Now let's put the value. Now you have done that k is 9. I'll just go back. I'll just go back again and put a as 2x squared, b as minus 1 over 2x, n as 12. And now we have known that the constant term k is 9. So let's do that and get the constant term. So right, I've gotten k as 9. So I'll just put a is 2x squared, b is minus 1 over 2x, n is 12, and now k is 9. Now let's substitute these values inside the formula. Now you recall the formula. Recall the formula that we have: n combination k minus 1 a raised to the power of n minus k minus 1 b raised to the power of k minus 1. So let's do it very quickly. Now I'll have 12 combination 9 minus 1 to 9 minus 1. A is 2x squared, all raised to the power of 12 minus 9 minus 1. Then b is minus 1 over 2x, all raised to the power of 9 minus 1. So I'll have 12 combination 8, 2x squared, all raised to the power of 12 minus 8, minus 1 over 2x, all raised to the power of 8. So I'll have 12 combination 8, then 2x squared, all raised to the power of 4, because 12 minus 8 is 4. Then here is minus 1 over, okay. Now when I have minus 1 raised to the power of 8, like I said before, when you have an even index, I will have a positive answer. So here will just be plus 1 all over 2x raised to the power of 8. I'll do 2 raised to the power of 8 first. 2 raised to the power of 8. The result is 256. So here is 256. Then x raised to the power of 8. X raised to the power of 8. So moving on now, let's find 12 combination 8. So 12 combination 8 is 12 factorial all over 12 minus 8 factorial, 8 factorial. And this is now 2x squared all raised to the power of 4. I'll do 2 raised to the power of 4. 2 raised to the power of 4 is 16. My punching calculator for that, 16. Then x raised to the power of 8. Because x squared raised to the power of 4, you don't multiply the index, you have 8. And this is multiplied by 1 all over 256 x raised to the power of 8. So now this can cancel this. So now 12 factorial, I will have 12 times 11 times 10 times 9 times 8 factorial all over 12 minus 8 is 4. So I will have 4 times 3 times 2 times 1, which is the same thing. So now this is multiplied by 8 factorial. So now this will cancel this. And then 4 will go into 12. 3 times 3 will cancel 3. 2 will go into 10 5 times. 5 times. Now let's multiply. This is 5. So I'll have 11 times 5 times 9. The result is 495. Now this is multiplied by 16 all over 256. So now I have 495 multiplied by 16 over 256. So let me just do the punching. Multiply this by 16. You have 7920 now. This is divided by 7920. So I have 7920 all over 256. So when it's divided by 256, the result will be 495 all over 16. So now this becomes your constant term. So if you remember when I was saying about constant term that there will be no x with your answer. So this is how you get your constant term, and I don't have that problem. Now finally, the III now is the term in x raised to the power of 6. So you just remember earlier that said after getting that 27 minus 3k, that was the index of x. Now I equate this to what? 6. I equate it to 6. And then when I equate it to 6, I'll get the special value for k. After getting the value of k now, I'll put it inside this formula again now to get the term in x raised to the power of 6. Let's get that very, very fast. All right, now let's get the final one, that is the III. So to find the term in x raised to the power of 6, that means he has to find the coefficient of x raised to the power of 6. So now to get that, like I said before, we have already solved the index of x. So when we solve this, we have 27 minus 3k. So now I'll equate it to 6. And then I'll solve. So 27 minus 6 will be equal to 3k. I just move this 6 here. Move the 3k there. So now if you subtract this, you have 21 will be equal to 3k. Divide this by 3. Divide this by 3. K will be equal to 7 because this will cancel this. K will be equal to 7. Now I've gotten the value for k. So I'm going to put this k now into that my formula. So this is the formula. Now you recall the formula. Recall the formula that we have n combination k minus 1 a raised to the power of n minus k minus 1 b raised to the power of k minus 1. So now we know that n is 12. So I'll have 12 combination 7 minus 1. A is 2x squared all raised to the power of 12 minus 7 minus 1. B is minus 1 over 2x. This is raised to the power of 7 minus 1. So I'll have 12 combination 6. Then 2x squared. So let me just be fast here. 12 minus 7 minus 1 is 6. 12 minus 6 is 6. So here is just 6. Then if I do that, 7 minus 1 is 6. So minus 1 raised to the power of 6 will be plus 1. So I'll just have 1 all over 2 raised to the power of 6. 2 raised to the power of 6. 2 raised to the power of 6. The result is 64. So I have 64 and then x raised to the power of 6. Now 12 combination 6, my result is 12 factorial all over 12 minus 6 factorial, 6 factorial. So this is now multiplied by 2 raised to the power of 6 is 64. So I'll have 64x raised to the power of 2 times 6 is 12. You understand how I got this? It's very simple. Now this is multiplied by 1 all over 64x raised to the power of 6. Now this can cancel this. Now let's find 12 combination 6. So I'll have 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial all over 12 minus 6 is 6. So I'll have 6 times 5 times 4 times 3 times 2 times 1 multiplied by 6 factorial. So this can cancel this. And then 6 will go into 12. 2 times 2 will be cancelled by this. Then 5 will go into 10. 2 times. 3 will go into 9. 3 times. 4 will go into 8. 2 times. Now let's multiply. So I'm multiplying 11 times 2 times 3 times 2 times 7. So the result is 9, 2, 4. X raised to the power of 12 all over x raised to the power of 6. So that's it. Now when I have something like this, x raised to the power of 12 all over x raised to the power of 6, I'll just subtract the index and then I'll have 924 x raised to the power of 6 when I subtract the index. So now this becomes the answer. So this is not the term in, to find the term in x raised to the power, this is not the term. The term in x raised to the power of 6 is now 224. So that becomes the final answer to the problem. So please do well to hit that subscribe button because I really deserve it. You listen now. I really deserve it. So hit the subscribe button and stay tuned for more amazing math content. See you on the next one.